Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communications at MLR Institute of Technology. Today, the video I'm going to present is about the string instructions and flag manipulation instructions present in 8086 microprocessor. Here are the overview of the today's presentation. So here string instructions, how the strings stored in the memory will get executed in the 8086 microprocessor, and what are the flag instructions, or we can say bit manipulation instructions present in 8086, and some of the machine control instructions present in the 8086 microprocessor. This video is a part of series microprocessors and microcontrollers. Previously, I have explained all the logical, arithmetical instructions, data transfer instructions present in 8086. This is the video of instruction set, last video of instruction set. So coming to today's presentation, so these are the string instructions present in 8086 microprocessors. These instructions are used for performing operations on strings. Strings are nothing but set sequence of data present in the memory. So how we will access the strings present in the memory, how we can manipulate the strings present in the memory. So these are the instructions present in string manipulation: move string byte or move string word, copy string byte, scan string byte, load string byte, store string byte, and repeat the prefix itself. So coming to the string instructions, particularly when we are dealing with the string instructions, the strings will always be stored in the memories, in particular microprocessor. So when we are performing string operations, there should be two memories or one register or memory. So when we are dealing with the string instructions, one set of memory will be located by the SI, data segment register, to hold the segment register, address, and SI, source index register, to store the offset value, to find the physical address of that particular memory location. And the second one will always use the extra segment register with the combination of DI, destination index. So source index and destination index are the registers which is used to hold the offset value when we are using the data segment and extra segment respectively while using string instructions. So here move string byte or string word. So the data present in one memory location, suppose MLRIT. So when I need to transfer this particular word present in this memory location to another memory location, then we can use this move string byte or string word instruction. So here I was giving the segment offset values in SI and DX. Here I was giving the segment values. So whenever move string byte or move string word instruction executed in the 8086 microprocessor, like loop instruction, it will check how many times the character or the data present will be moved, the bytes will be moved. Here that number of times we need to mention as a count in CX register. So that's why here CX register is filled with 5. So 5 locations, 5 bytes of memory, 5 bytes of strings can be moved to the other location. So coming to move SB, first M will be get stored. Next CX register will get decremented when CX register is not getting 0, then only again the loop will be executed. M will go, L will followed. Next again CX register will get decremented until CX register is 0, then this move string byte will execute, and 5 bytes, here I have mentioned CX register as 5. So 5 bytes of strings present in one memory will be copied to the other memory locations. So this is about, if we are mentioning SB, then string byte will be moved. If I am mentioning SW, so word, 4 bytes of data will get moved. So coming to the next instruction, CMPS, compare two strings. So it will compare the strings present in two memory locations like move. So if SBS is there, here SSB is there. So there is the comparison between these two locations. So how many times it will get compared? CX register is 5. So 5 bytes of data will get compared. So first Here I was using comparing byte. So here two things is there, compare string byte, like it will compare byte of the strings, and it will compare string word. So 4 bytes will get compared. So here in this particular instruction, compare bytes, first data present in one location will be compared with the data present in the second location. So if these two get equal, then only the execution will move to the second location, and then the second location of first address will compared with the second location of second address. If these two bytes are equal, then only the execution will move to the other. Here in this particular case, here we are getting not equal. So B and S are not equal, so there executes and there ends the execution of this particular instruction. So coming to the next instruction, scan string byte or string word. In this particular instruction, the data present in the accumulator, either AL register or AX register, byte here byte or word, will compare with the present memory location ES, the second location. So extra segment location. If I was doing AMPS, so when I was searching in this particular memory location, AMPS data is there. So here what are the so here move a CX. So until 5 bytes it will check. So coming to scan SB. So it will check scan SB. So here I was moving AL with the value 41H. So in this particular instruction, 41H is the ASCII value of A character. So string means it will search A by A character in this memory location. If A character is fine, then it will end the loop. So it will execute the label found. So if it is not there, it will execute until 5 bytes. So if it is not there, it will end the execution there itself. So coming to the string instructions of load string byte. So whatever the data present in DS and SI is moved to the accumulator register AL or AX. It will search until count equals to 0. If the data present in the DIS and SI location will be moved to the, so the data in the memory will be loaded to the accumulate. So coming to the store instruction, here the exact replica of the load instruction. Here we are storing the data present in the accumulator into the memory register. Everything else is same. So coming to the next instruction, repeat prefix with string instruction. So here repeat, REP instruction is used to repeat until the CX register is getting into 0. Here I was using the repeat move SB. Move SB means it just copies the data from the second location to the main location or main location to the secondary location. So here while using this instruction, when we are mentioning repeat, then only the CX register will get decremented by 1 and it will execute the next memory locations. So it will copy the first. So here, if this is the main memory, first memory, and this is the second memory, the data present in first location will be copied to the first location of second memory, and then CX register will decremented. This execution, whatever that I told, this execution will be repeated until the CX register will get 0 if we are keeping repeat instruction only, until unless it will execute. If I was writing move SB only, previously I have already told in the location here, compare B means it will compare only first locations until we have written here repeat instruction. Then only the second byte will be get compared, the third byte will be get compared. Until unless we didn't mention this repeat instruction, the comparison or scan, store, everything will be only first byte of the string. So these all are the instructions present in the string instructions of 8086 microprocessor. Next, coming to the instructions of flag manipulation instructions. These all are the flag manipulation instructions present in 8086 microprocessor. These instructions is also known as bit manipulation instructions. So why it is called as bit manipulation instructions means these are the instructions used to alter the single bit present in the flag register. So CLC means clear the flag register. STC means set the, here CLC means clear the carry flag. Here STC means set the carry flag. CLI means clear the interrupt flag. CLD means clear the direction flag. STD means set the direction flag. STI means set interrupt flag. CMC means complements the carry flag. These instructions, all these instructions is performed on the single bit present in the flag register. So coming to, let us explain with some examples. Here in this first program, the AL register is copied with the data 585H. Those are hexadecimal numbers, and BL is with 83H. So another instruction is execute the addition between AL and BL register. So the data present in these two registers will get executed. 5 plus 3, 8. Now coming to 8 plus 8, it will be 16 in decimal number. But here the execution will always be in the hexadecimal number. So how we will execute 60, how we will represent 16 in decimal number into hexadecimal number? So it will always be 1, 1. So 1, 1. So here we are getting 1 with the carry 1. So here when we see here carry is enabled. So I didn't want that carry for the execution of the program. So I need to clear that particular carry bit. So that's why here CLC instruction is used. Whenever CL here until addition instruction CL flag get 1. But after execution CLC clear carry, this carry flag will get 0. So any further executions of the program we can see this. Next coming to the next program, here CMC. CMC means complement carry register. In this particular register, if we are getting carry as 1, either you can clear the carry register or you can complement the carry register. So while we are complementing here, carry register is 1. Now it will become 0 because complement carry instruction is there. Okay. Next. Coming to the machine control instructions present in 8086 microprocessor. So some of the instructions are halt instruction. It will halt the execution of the program or it will stop the processor. So NOP, no operation instruction. So for debugging or just to kill the time, we can use this no operation instruction. No, next waiting for the hardware signals to get fetched. And next lock instruction. Lock instruction is, I have already explained this lock instruction in 8086 pin diagram. So whenever the processor executing any program, it need not to give those system buses to the other processor or the other peripherals which asking for the system buses or all the buses present in the 8086 microprocessor. So if this lock is executed in the program, then the processor is not giving any system buses to the other processors or the other external peripheral devices which is connected to the 8086 microprocessor. So these are the instructions present in 8086 microprocessor. So until I have discussed the string instructions, flag manipulation instructions or bit manipulation instructions and machine control instructions. And these instructions, so what are the applications of these instructions? To perform any operations on strings or to perform, to display the string, everything. So these string instructions will get worked. So to perform, to check whether the status, to manipulate the status of the outputs, we can use flag instructions, and to control the execution or to control the hardware which we are giving to the 8086 microprocessor, then we can use machine control instructions. So thank you.